Right, good morning, everybody. Another warm welcome to a yet another Wednesday webinar. This week around, as the title suggests, we're going to be talking about gas and the challenge that is getting off mains gas. This is a new presentation. I was busily writing the last bit of content for this last night. And so hopefully this is kind of new material and nothing too kind of repetitive that you've heard before. It's great to get some new content down there and get the discussion going. As usual, we'll try and do maybe kind of 45 minutes presentation and then open it up to questions. I know lots of people have questions about gas. And so I say the focus on this is really about why we should be coming off gas. So a bit of background there and how we kind of transition. And I've taken a look at various things here, as you'll see, not just kind of, looking at the calculations and stuff that you need, but taking a bit of a kind of a wider step back and looking at how we transition off of gas in the built environment. So as usual, just at the top of the tree here, for anybody who is new to these webinars. Mesh Energy is a kind of an independent and holistic energy consultancy practice. We work with architects predominantly, but wider design team members and of course end clients to deliver more sustainable buildings and more successful buildings as well at any scale. We're seeing all kinds of fantastic projects come up as well as a lot of projects which have their own headaches and opportunities. So we work actively with the design team on behalf of the end client. We're not sponsored by any manufacturers. We've got an incredible toolkit and an incredible team to help you navigate an ever-changing sustainable design environment. I'm kind of preaching to the converted here. You guys will have joined this webinar for the first time ever through Meshwork entirely. And we spent the last few weeks transitioning over to doing our webinars through the Meshwork platform. As you guys will be very, very aware, the platform is completely free. We decided to open it up to everybody without cost. Do invite your friends and your colleagues though. You can now invite people from the platform. So if you know of anybody who you think the platform would be of interest to, who wants to continue the discussion about sustainable design and wants to be on these webinars, then do share the link about. We'll obviously continue promoting it, but a recommendation from yourselves is always a really, really good thumbs up. And the latest stats actually on the platform, the membership of the platform has grown about 100% in the last week. So getting a lot of traction now. We're going to get some great specialists and some great content on there. And as you will see, a building amount of events from across the sector as well that we're featuring on there. Right, so today, let's focus on today. What's coming up? So I split this into kind of two parts, really. The first part is why we should be coming off gas, where we are today, looking at the decade ahead, but also more importantly, just looking at what's around the corner. Forget 10 years or the next 8 years, 8.5 years, what's going to happen the next 1 or 2 years. And then the second half of the presentation is about how. So think about how we tackle that transition, looking at education, looking at design, and kind of finishing up on some places to start. As we've said on many of these webinars, it can seem really overwhelming about all the changes that need to happen. Invariably, you start with one thing and then you do another thing, you do another thing. You haven't got to do 50 things at one time. So we'll give you some ideas of where to start and we'll wrap up at the end with some takeaways. So where are we today? Where are we today? There's lots and lots of news articles about where we are, about decarbonising the United Kingdom. But I found this graphic actually on the Climate Action Tracker website. And this kind of tracks all kinds of documents and releases by the government, all kinds of things. And this I thought was a really, really simple graphic, which would be worthy of showing you guys. And this shows us where we've come from since 1990, what's going to happen over the next kind of decade and where we've got to get to by 2050. And as we'll talk about some of the government commitments, but I think this is quite a handy graphic here. In blue, this actually shows us what's happened as a result of COVID. So the solid blue chunk there, you can see, we think the emissions long term actually will have dropped off and been positively affected by quite a negative overall event. And as you can see, we're kind of on track. The gradient starts getting pretty steep by the end of 2030, but it's all kind of sensible. And for those mathematicians in the room, there's every chance that if you carry on that trend from 1990 to where we are today, that we will get to net zero carbon by 2050. There's still plenty to do, but this shows that we're on track. You know, we're not having to massively reinvent the wheel. We've got to get pretty serious about it, kind of like today or yesterday. But it's all doable. It's all doable, absolutely. With gas particularly, one of the biggest challenges in decarbonising the built environment is those existing buildings. New buildings are easier, they're a kind of a blank canvas, but existing buildings are the big issue, as you will probably have kind of either be aware of or know in your gut. The problem is we have 23 million existing homes at the moment, and 85% of them are on natural gas, so have a mains gas boiler. That is a vast, vast, vast amount of boilers that need to be changed or take on an existing fuel, or homes that need to modernise over the coming years and decades. So I thought I would just share these numbers if it was at all unclear that the magnitude of what has to happen to get off gas. And this is when you look at the proportion of houses that use different fuels. Again, gas central heating, 85% there. These other things, electric portable heaters, electric storage heaters, and even oil, actually. I mean, oil, that was a surprise for me, how low that was. But gas by a country mile is the big predominant fuel source. And so if we can get off gas to something more sustainable, then that's going to solve a really, really big problem for us. But the numbers are quite significant. And I thought I'd also show you guys this graphic, which is how, for those of you who are familiar with what an EPC is, this is how EPC ratings have been changing just over the last 8 years. So in the green band at the top here, it's EPC ratings from A to C, D in yellow, and E in light orange, and F and G in kind of the darker oranges. So as you can see here, you know, the last 8 years, UK households have been improving. They have been getting more efficient. There's still a lot of work to do to get the vast majority in the ABC territory, but the trend is kind of getting there, and I'm sure that will accelerate in part over the coming decade. It has to, but there is no doubt that there's a big challenge with insulating existing buildings. So the decade ahead, the government has committed to net zero carbon by 2050. And more recently, only in the news a few weeks ago, they committed to a 75% emissions reduction by 2035. And this does go to show that the work that's being done over the next 15 years really needs to move the needle. You know, if you were to project that for another 15 years to 2050, we'd be well below net zero. But anybody familiar with the Pareto principle, the 80-20 rule as it's known, knows that there's obviously low-hanging fruit. There's easier stuff to do sooner, and there are bigger gains that can be made in the short term. And then the really hard slog comes in those latter years as you've done the easy stuff, and it gets progressively more difficult to get to your goal. The other big thing as well, which is changing, and we will see change over the next couple of decades, is all of a sudden, big Goliaths of the commercial world have started announcing what their commitments are. And this has obviously come from a lot of social pressure, but also governmental pressure as well. So you've got people like Amazon and Google who've said they're going to be net zero carbon by 2040. And then Microsoft, Apple, and Facebook, who said that they're going to be net zero or have net zero carbon emissions by as soon as 2030. All of these companies use a vast amount of energy, but Amazon and Google particularly given the size of their businesses and the kind of business that they do and the processes that they run to deliver value to their clients, they reckon that's going to take them another 10 years to get there. And you guys will have seen adverts on TV from some of these companies. They're pretty serious about it. And particularly if we bring this back to housing, institutional developers, we've had more and more discussions with institutional investors and institutional, guys at the top of the tree handing out money, and carbon commitments and some kind of roadmap to net zero and sustainability is being seen as a really key thing in proposals that they're seeing before they start handing out money. So some pretty serious commitments being made over the coming decade or two. Now, what I thought I would show you in the 2020s, we're already 1.5 years into the 2020s. We've got another 8.5 years to go. I can tell you now that within this decade, gas boilers will no longer be allowed to be put into buildings, into new buildings. Any building comes in the 2030s. I'm just going to do a really quick straw poll here. So open your chat box and give you 10 seconds to write down, well, 4 numbers, hopefully. But if you open your chat box, and I'm going to give you 10 seconds to write down at what point during the 2020s gas boilers will be, through regulation change, essentially a non-viable fuel source to put in new builds. So open your chat box, bang in very quickly when in the 2020s you think that regulation will change and no longer will gas boilers be allowed to be put in. Right, cool. We've got tons and tons and tons of answers here, which is exactly what I was after. We've got everything ranging from 2022 to, what do we got? We've got 2028 there, we've got 2030. Good. Yeah. So, okay. So we've got an 8-year range. We've got everything from kind of 7 months time to the end of the decade. So what I'm going to show you here is how the decade is going to unravel as far as based on what we know, kind of regulation in a really simple to understand form here. So we're here, and this is the benchmark for kind of 0% carbon emissions reduction. The beginning of next year, the end of kind of Q1, we think maybe the start of Q2, there will be a new set of building regs. These are going to come into law, as I'm going to go on to explain, this year, but they'll actually come into effect next year. So these are the new building regulations, and a 31% CO2 or carbon emissions reduction target is being set through a balance of kind of fabric and emissions. The Future Home Standard, if you've heard of this, we can briefly kind of cover this further on, but if you haven't heard of this, the government has done a big consultation on kind of the Future Home Standard and really putting a much firmer flag in the ground in the middle of the decade. And what we're talking about here is a 70% carbon emissions reduction in the built environment for new buildings by the middle of the decade. And who knows what will happen at the end of the decade. So to answer your question in the chat here, what they're saying at the moment is the new regs coming in, you can still put a gas boiler in and make that work and get that 31% reduction. But when it comes to the middle of the decade, so 2025 at the moment, what that means is that putting a new gas boiler in, based on the calculations that are done, the SAP calculations that are done, gas boilers will no longer be compliant. So the middle of the decade, so we've got 3.5 years to get our heads around putting something else other than in the building other than gas boilers for new build properties. So there's your answer. If you guess 2025, Yulia, we've got, well, Daryl hedged his bets. He said 2025, 26. Anna, we've got loads of people guessing 2025, 26. Here we've got at the bottom. Glenn, well done. So a really good set of guesses there, but the middle of the decade is when gas boilers will no longer be allowed. But there's a hell of a lot of changes challenges to get over. And I've kind of clustered these. We're not going to go into these line by line, but these are some of the challenges. Some of you will be aware of these, others will maybe not aware that these challenges exist. But the big one, as you've probably picked up on, the fact that you're on this webinar means that you know that you need to educate yourself better. Meshwork, and that platform is built around better education. So the first hurdle is widespread kind of consumer and client understanding, and that kind of goes hand in hand with you guys as architects and design professionals understanding what needs to be done and understanding the risks of not learning. So you've got to get your head around it and then help the clients and consumers understand what's changing. And of course, social media, TV adverts, all kind of media help do that. But there's a lot of consumer understanding and change that needs to happen as well. But ultimately, they're guided by you guys as design professionals. The actual professional design standards need to change, and there need to be further training and education around those. And also the rate of change of learning needs to change. We'll all be aware of the network effect. Imagine you had a line of people whispering to one another what was happening. By the end, it would take you a long, long time to get to the end of the chain. And by the end of the chain, the story is likely to have changed. Good old Chinese whispers. But if we can centralize what we're learning and share in a kind of a networked effect, what we're sharing, the knowledge transfer happens far more quickly, and you find out the kind of the key details sooner as well. But also there's a big challenge ahead with training product installers. Changing 85% of 25 million gas boilers over the next couple of decades is going to take a pretty serious product installer movement. And there's a lot of work being done with apprenticeship schemes and existing training schemes to make sure that gas boiler installers can transition over to alternative technologies. There's big financial challenges. The Green Homes Grant, if you're familiar with that has failed yet again. I think it's the third attempt by the government to help with refurbing of buildings. The Renewable Heat Incentive Programme is still going strong, but that has limited time available to it before a replacement programme comes in. One of the other big challenges is that fossil fuels are still very, very cheap. Mains gas compared to the cost of electricity, even if you use it through an air source heat pump, is very, very competitive. And in existing buildings, in some cases it's on a par, and gas is cheaper than doing something renewable. So something has to happen with fuel prices as well. But also the technology going in. Heat pumps for a long, long time, which we'll talk about as a viable alternative to gas boilers, have been relatively expensive. They're made a lot in Europe as well, which doesn't help us in the UK. But there will be increasing price pressure on these products, and their margins will tighten. So the prices will come down. And invariably, because of the technology involved, they will be more expensive than gas boilers. But again, that will be something else that puts developers, homeowners, and other building trades off sustainable products, is if they cost a ridiculous sum of money over and above, a kind of a fossil fuel option. So for those who are trying to make progress, bringing down those prices will really help as well. And then technical progress as well. Again, kind of, it's still going to be reasonably inconvenient to insulate buildings. So thinking of new and kind of sensible and fantastic ways of insulating buildings without really causing a huge headache in the process is the kind of the holy grail of treating existing buildings. And no doubt there'll be some magical materials that come to light over the next decade to help us do that, and hopefully low carbon as well. But also, installation of renewable energy products in buildings just needs to be more simple. There's a fair amount of complexity in sustainable product installation. And again, there's a lot of work being done to try and simplify that so that sustainable products can be put in faster, and as a result, their installation costs can come down because the labor involved is less as well. So there's a fair number of challenges there. And as we'll see, there's only some really, as people on the call, that we have any effect over. Don't think for a moment that we individually can change all these things, maybe as a group, but in our day-to-day work, there's a fewer number of these which we should really focus on. So just around the corner, forget the end of the decade, forget the middle of the decade. What is happening in the next kind of year or 2 years' time? This is what is most important to us, to make sure that we continue to de-risk the work that we're doing and educating ourselves in a proper fashion. So what we're saying is the regs are changing at the end of this year and coming into effect early mid next year in 2022. But those regulations are coming. That they have been announced, and they'll be made law, as I say, by the end of the year. And they're talking about a 31% carbon emission reduction in Part L, which is about conservation of fuel and power. And that will be a mix of improving nominal fabric U values, as well as looking at sustainable technology. And it will have to be a blend of those two. During the consultation, they did consider just doing renewable energy and keeping fabric the same, but luckily common sense prevailed, and they will tighten up both of those to make sure that that 31% carbon emission reduction is met. So that's a fair old jump, and this is compared to today's regulations. And it's not easy getting down to that value. You can continue with a gas boiler, but if you do, you're really going to have to tighten up on the rest of the building. One of the other changes as well coming in, just worthy of note, is that Part F, which is about ventilation, is slightly changing. There is an improved focus on building air tightness, and there's a bit of a change on testing methodologies as well. But the big part here is conservation of fuel and power. And just to round that out, based on what we know, we think there's going to be a new part to the building regulations on overheating. I think you may have heard us mention this before. That's going to be a new Part S. Overheating will be taken out of SAP calculation bit. At the moment, it's kind of low, medium, or high risk for the entire building. And there will be an overheating part in there, which goes into more detail. And as I say, this is coming in at the beginning of next year. So you need to get a head around this. So as well as talking about carbon emissions reduction, there's other parts as well, which you need to get your head around. So what? So the fact that the building regs are changing, you know, why should you guys care? Well, if you're talking to clients about developments where they're looking to go in for planning into next year, maybe you're in very, very early stage discussions with them, and maybe it's a big scheme, which you know, takes a long time to get through planning. There's every chance that some of these new regulations will affect those buildings that you are talking about right away. And if you think they might be, or even just the fact you want to get ahead of the game, might be worth understanding or doing a little exercise and understanding, based on whoever's doing your SAP calculations at the moment, what would it take to meet that 31% reduction? You could do a quick little desktop exercise with your assessor, and just imagine the fact once you put the numbers in for the building, it's quite easily to move the levers in a SAP calculation and give you that 31% reduction. So just an understanding, or a beginning of understanding what that 31% reduction looks like in your own head, could be increasingly more important as the months go by. But also understanding overheating analysis. What is it? What does it cost? What are its outputs? Not being scared of these new things, understanding that they will better our building stock as we improve the design process, and knowing that we will all benefit from better analysis at an early stage. And as I say, ultimately de-risk the projects that we're involved in, rather than being caught out and finding ourselves down a kind of a dead-end road with the designs that we've spent all of our love, care and attention on. So start focusing on some of these key things, and this is why it matters, in order not to get caught out by these new changes. The other changes coming around, I guess, again, kind of coming back to kind of gas-related technology, is the technology progress. You know, fusion is a long way off, so we've got to have a look at the technology that we know and some of the new technologies that we're talking about that could replace gas. I don't think there is any doubt that widespread electrification of homes is now really you know, a foregone conclusion. There are more and more EV points going in. We use more and more electrical devices every single day, even though they may be getting more efficient. You know, our love affair with electricity isn't going to go away. And particularly with some of the recent announcements by the government on their heat pump strategy, heat pumps use electricity. And so we've got to improve the electricity network in the UK and prepare ourselves for better electricity supplies into those buildings. And the reason for that is, you know, heat pumps, and particularly air source heat pumps, are a very, very, very viable replacement to gas boiler systems. There's some work to be done on improving the insulation of existing homes and some of the ways that we get that heat into the building. And air source heat pumps are, you know, in some cases are there. You can get some higher temperature air source heat pumps, which you could replace a gas boiler with straight away. So as efficiencies of heat pumps and stuff increase, you know, we need to look out for and get ready for greater electrification of buildings and using more power and making sure we've got enough services to the building and the network is ready. But I'd say there are a number of challenges, but really the heat pump movement will ratchet into high gear over the coming decade to replace gas boilers. But we can't talk about other technologies without talking about hydrogen boilers. Again, hydrogen boilers are being written about more and more and more. I've answered numerous questions about hydrogen boilers in past webinars that we've done. There is a tendency for some people to think that hydrogen, because you get oxygen and water, or oxygen and water are used to produce hydrogen, and once you've burnt it, you end up with some lovely, nice stuff at the end as a byproduct. That hydrogen is the kind of solution to all of our problems. There's two issues with that, and there are various studies. We're not going to go in depth here, but the general headlines here are the fact that in hydrogen's favor, using the existing gas pipework distribution network is a big tick. We can use that pipework, we can start introducing hydrogen into the gas mix and almost kind of cutting the two together. And it's not a big leap to get from a gas boiler to a hybrid kind of gas and hydrogen boiler. And there will be some manufacturers that will be doing that as a to plug the gap. What numerous studies have suggested, though, is whilst hydrogen seems great on the face of it, and we can use that existing infrastructure, there are issues with storing hydrogen. And when you look at the overall cost of providing hydrogen to homes, it's actually relatively carbon intensive, and the energy involved in storing it is massive. The other slight issue is the fact that far smarter people than me reckon that the penetration of hydrogen into the overall kind of heating mix will only be about 15%. We're not expecting a big seismic change over to hydrogen boilers. I guess the best analogy that I can think of here is kind of a bit like hybrid cars. You know, I think hydrogen boilers, if they do come in any kind of meaningful way, there'll be a bit of a stopgap. But I think there'll be big competition between hydrogen boilers and air source and ground source heat pumps going into buildings to replace gas as that gets phased out. And there's no reason really for new buildings to put in anything else other than air source heat pumps if the cost is right. So that's really my kind of 10 penneth worth on hydrogen. It is viable. I'm not aware of a huge amount of people selling hydrogen boilers, but my guess is that they will upskill gas engineers to make sure, and they'll be the same box. They'll just be have a slightly different tech in them to burn a bit of hydrogen and a mix of gas at the same time. So education and training, you know, how are we gonna transition from gas? Well, as I said, education and training is a big part of this. There are limited effects that we have as professionals over the financial things. Unless we're in government, we probably have little effect over what subsidy programs are coming out, or the cost of fossil fuels, or the cost of renewable system prices, or in fact the technological progress that's being made from various manufacturers. But we can have a big effect on education and training of both ourselves and of the people that we interact with and our clients. So these three that I've highlighted at the top are the ones I believe we have the biggest effect over. And the first place to start here is with the client. Clients, in my experience, are becoming so knowledgeable now. There are, you know, the internet and various things that are watching, and just the appetite of clients to learn about this sustainability and what the other options are is ferocious. And I know it's scary for a lot of us as professionals when we start talking to a client who knows almost as much as we do and sometimes more. But education starts with the client. Not everybody's in that position. Some clients have already, have in their own minds, they're converted. They don't need explaining to. They might need explaining some of the kind of the techie details, but some clients in their mind are already converted and are already off gas and don't see the point. But a lot of clients still need guidance, hand-holding, justification, and they need to be shown the kind of holistic impacts of changing away from something that may be cheaper, changing away from something that most installers know how to do. And so there's a big client education piece, walking them through and just giving them, kind of fair, independent information. And that starts with us as professionals. And, we are trusted to give the right information out. And in order to do that properly, we need to better educate ourselves. We need to go on webinars. We need to learn from colleagues. We need to read books. We need to ask other people who've done something similar, share case studies. I say this is a far more effective, and we need to take responsibility for our own education here, not hoping that other people will kind of figure it out and we can just kind of sit there as dum-dums and magically it will work out. We all need to take responsibility for our own independent education. And as I mentioned before, the most effective way of doing this is sharing, dropping those barriers to, the silo that maybe you're used to working in, or desperately clinging on to information you think only you know, and being very secretive about how you learn stuff. The best way to do this is having more and more discussions with all kinds of trades to kind of pick up those tidbits and understand how the work that you do and what you know fits into with what other people know. It enriches our education and makes it far more enriching when we speak to the client, because they very quickly pick up on the fact that you only know one thing, or actually you've had multiple discussions and this is your kind of balanced opinion. So education and training here is a big piece. And as I've said in previous webinars, the next 2 or 3 years will be some of the hardest and most furious learning most of us have done probably since leaving university or college. And there's a lot changing very quickly, and it's affecting all of us. The other part of this is kind of zooming in a bit, is a bit more about focusing on efficient and robust design. I'll bring you back to the good old-fashioned energy hierarchy that we've mentioned numerous times here before. So starting with the basics, the way that we transition from a fossil fuel to a more efficient, sustainable technology is just understanding the simple principle of physics. And this starts with building location, orientation, and form to reduce the surface area as far as possible of the building, looking at how we insulate that building as best as possible, looking at how leaky that building is and how we recover heat from that building, then looking at super duper sustainable technologies, then looking at low energy appliances and lights and working the way down, and then finally relying on how we use these buildings. As we've said before, the best way to spend money and the best way to save energy is working from the top down here. There's no magic here. This is just logic and being better informed as part of the design process. And so if you can get your head around the kind of the common sense involved in these kind of stages of decent design, the next thing is to get your head around how you design. And this is going from linear design and thinking in a very kind of linear way. The client tells you what to do. You then absorb that. You then tell the structural engineer what needs to happen. The structural engineer then figures out the building can just about stand up or stand up effortlessly. And then you do the MEP and all these other kinds of things. And then the builder does his bit. That is very linear building design. And rapidly, we are getting our head around the fact that that can no longer continue. And it has to be a very kind of hub and spoke approach. You need to have a solid understanding at the center of your project from a very, very early stage. That could be a great team, a collaborative team, the right tools, or a mixture of all of the above to make sure that you can cover off the design in all of its stages and, as I say, de-risk it. So going from that linear approach to that hub and spoke approach, for some people will be a steeper mountain to climb and affect that change. Some are already on board with this and get it, and they're working with their clients and the rest of their team to understand costs and the right kind of blend of advice that they get as the project continues. And this is the main thing here, really, you know, is with better design comes better goal setting, better sustainable goal setting, and then being able to intelligently kind of push those doors rather than a kind of a shotgun approach here, more intelligently pushing doors and using analysis to help you out there. Sustainable design, again, bringing this back to how we get off gas. The only sensible way that we deliver this commercially is by getting better and getting more efficient at designing low energy buildings. As soon as we start adding cost to sustainable design because of our inefficient design process, that's going to turn clients off because every single client has a budget. And so if we can streamline that, keep costs down, it becomes an easier decision for those who are slightly more cost sensitive as part of the design process. We can keep our fees under control. It doesn't become a luxury, and it just becomes a natural progression. I'm not going to focus on this really. This was just some kind of key things to do on these during these stages. So zooming in even further, let's talk about some kind of practical details. We've started with education. We've talked about the design process. I hate woolly webinars, and that's why I always like putting some numbers in here. These are some numbers which will hopefully guide you in showing you what your buildings are going to have to look like for new builds to be able to get off gas sensibly. This is a kind of a Frankenstein of a table that we did before, but we've got at the moment the current building regulations looking at the various U values, what your heating and hot water system might be, what your ventilation system might be, and any energy generation. So your current regs, pretty standard stuff, nominal U values, gas boiler, mechanical ventilation. For the targets that are coming up, and these numbers have actually come out of the consultation document that the government came back with, so do pay attention to these. These aren't just ones that we've made up. The 2021 building regulations targets have tightened roof U values and window U values. Air tightness hasn't changed. Still got a gas boiler in there, still got mechanical ventilation, but they are suggesting solar PV and tightening U values to get to that 31% reduction. If you can't put solar PV on there, you're going to have to tighten the U values as well for the buildings. This gives you a kind of a flavor of the U values and the type of technologies going in to meet the 2021 regs. In the middle of the decade, they tighten again. So you're looking at even tighter U values. Now you can't put in a gas boiler. Now you've got to put in heat pumps. You've still got mechanical ventilation. In fact, air tightness is still at about the same kind of level that it is at the moment. So they reckon to meet the future home standard in the middle of the decade, this is what you'll be looking at. And to give you an idea, we've banged on numerous times about the REBA 2030 climate challenge. This is the REBA 2030 target U values that you're going to be getting to. So air tightness is quite tight. U values are similar for the roofs and floors. The walls are tighter, but windows, floors and roofs are where the future home standard are. There's solar PV on there, and you've got mechanical ventilation, heat recovery. So you can kind of see the progress here, and in line with what the government's suggesting and then what REBA have put in place here, there is a kind of a logical progression to get to the end of the decade. Those who are doing the REBA 2030 target stuff today, happy days, you're well ahead. But this does go to show how compliance changes, future home standard, which will be announced in the next kind of couple of years, and the REBA 2030 targets, which are very much voluntary, how they align, and you can kind of see the story that's being told here. And other areas of the project you need to be aware of. Moving away from fossil fuels and making sustainable buildings, just looking at running costs, more effective and cheaper to run is all around building fabric, air tightness, and the way that you get that energy into the building. You know, you've heard us say this before, if you can lower what we call the flow temperature through the heating system, the air source heat pump or hydrogen boiler or gas boiler or whatever doesn't need to work so hard. And if you've got underfloor heating compared to smaller radiators on the walls, that means that you can keep the occupants nice and warm in the middle of winter at a very, very low temperature. And the lower these flow temperatures, the more efficient the system. But here are the kind of the top 5 things that we need to bear in mind as we start thinking about coming off gas. One is plant space, particularly for, let's talk about air source heat pumps. You need space in the outdoor garden or up against the house for the external wall unit. There's no such thing at the moment as a combi air source heat pump system. So you're going to have to look at hot water cylinders, even for smaller properties, and for larger ones, a larger hot water cylinder. As I say, the emitted design temperatures, so a nice low flow temperature underfloor heating system or nice low flow temperature radiators. We talked about electrification of heating systems coming along. More and more people now are talking to their network operator, and you need to, at as early a stage as possible, look at the electricity supply for the property. Rickety old single phase supplies aren't going to last or be appropriate for much longer, even in quite small homes. Once you've got electric vehicle charging points and air source heat pumps or ground source heat pumps in there, you're really going to need to talk to the network operator to make sure that it's even feasible before you nail down the strategy. Placement and noise considerations. This is particularly in relation to the outdoor fan unit for air source heat pumps, but also more widely taking greater care and selecting installers. There are not tens of thousands of sustainable product installers at the moment. There are hundreds. So you need to be more careful about who you select. There will be more cowboys as this becomes more advanced through the decade. And again, as I've mentioned before, take your time to select installers as you go along. And all of these things you will have to consider in more detail on sustainable projects. So where to start? There's lots and lots of things you could do, but where should you actually start? Well, I would say across the board, again, we're having many, many discussions with people about how you do this cost effectively. You need to start benchmarking your current buildings. Every single practice, if you're an architect or a designer on here, will design to a different standard. Some of you will just scrape by building regulations. Others will be pitching for REBA 2030 and beyond. But look at the way that you design buildings at the moment. And I don't know, benchmark the last 5 that you've done, maybe 5 domestic dwellings that you've done or 5 commercial properties that you've done, and find out where you sit. Are you designing buildings that are quite progressive, or are you designing buildings that are not? Knowing what you've got to improve is really, really critical. I don't think I've mentioned this before, but you guys may be aware of our free embodied carbon calculator that we do. I spent the last week improving on that in relation to the REBA 2030 framework. And for those who are aware of that, you've got overheating in there, you've got operational energy, you've got embodied carbon, and you've got water usage. And we are very, very close to offering a free tool in line with the embodied carbon calculator. Very, very simple to use. At REBA Stage 2, you can benchmark your designs against REBA 2030, REBA 2025, REBA 2020, BREEAM to a degree, Future Home Standard, all kinds of other things. And that's the tool which we believe you guys should have in order for you to benchmark. So knowing where you are is a critical first step. Beyond that, start talking to clients about changes in emissions and possible impacts. So now that you guys know that there are regulatory changes coming and what those look like as far as building design are concerned, start proactively talking to your clients about what that could mean. Prep them, make sure that doesn't come as a surprise. They're going to be relying on you to de-risk their project and make sure they aren't getting surprised. So get your own head around it and then get the client's head around it. And don't go in, all guns blazing. once you know what things need to be tweaked, then you can have a much more kind of meaningful discussion rather than, scaring the hell out of a client and then kind of inadvertently turning them off because they think it's too risky to even build the building in the first place. Or you could, or this is an and or an or, identify how you could improve your current design process to design more sustainably. Again, we've done entire webinars on this, but take a genuine and impartial look at your design process and have a think about, are you benchmarking designs? Could you get some better understanding, maybe in the design stage SAP calculation phase, or I don't know, maybe you start to model overheating in the building, whatever it is, have a think about how you can strengthen your early stage design process to make sure that, again, you're not going to get caught out by these changes in building design and regulations. And in the process, learn something about the way in which you design buildings. So have a look at your design process, figure out where the weak areas are and where the big question marks are, where you might need to rely on external consultants or where you need to educate yourselves better internally. But finally, whether you do any of this, you've got to keep learning. If you keep learning, you will remain relevant. If you stop learning very, very quickly, you will fall behind your team, your competitors, your clients. You'll have less to talk about, less engaging. And if you're a business owner, that only means one thing, and that probably means that your business will be staying the same or shrinking or going out of business pretty quickly. So do keep learning, ingest as much as you can do, and then make it relevant for your particular practice. So the key takeaways: change is coming. There's no two ways about it. Gas has a limited life for new buildings, middle of the decade. What I didn't say actually is that by, I think, the early 2030s, they're going to ban gas boiler installations outright for all buildings, but middle of the 20s for new buildings. The next 4 years will bring big changes to emissions regulation and building design. There are tons of challenges, only some of which you have any kind of meaningful effect over. And the biggest one of those is education of yourself, both technically and more holistically for building design. Understand what a low energy building looks like. Understand what a building that's going to be fit for 2021 regs actually would be. Would it need to have a heat pump in? Would you need to have a certain type of U value for the walls? And what would that look like based on how you normally design buildings? Change your design process to make sure you de-risk it, and better educate yourselves and your clients in the process. It will be a far, far easier journey if you're educated and your clients are as well. That's me done. Wrapped up. I know we've got some messages here. Do feel free to drop your messages in the chat box. We'll try and answer as many of them as we can do. Yeah, let's give it 10 minutes and see how many we get through. So do feel free to ping your note in there. Is there going to be a ban on gas boilers in existing buildings? Yeah, Mohammed, we reckon 2033, 2033 is when they're going to ban gas boilers in existing buildings. So you won't be able to replace an existing boiler or put a new boiler in from 2033, which seems like a long way away, but that's what they're saying at the moment. Richard Coles, do you think that we are stuck with green premiums until technological advances catch up? Yes, in a word, Richard. Yeah, it's, these technologies, we love technological advancement in so many aspects of our life. And it makes me chuckle when trying to make progress and decarbonize the built environment, people whinge about the fact that it's actually going to cost money to do that. It doesn't help that we've got cheap fossil fuels, but the technology that is going into even hydrogen boilers, air source heat pumps, ground source heat pumps, this stuff is highly engineered stuff, and it does some incredible work. And so to expect that as, at the same price as a gas boiler is simply ridiculous. you know, it's like saying, you know, I want to pay the same amount of money for a Monet as something my 5-year-old son did in nursery. Funnily enough, there's a hell of a lot more work that's gone into the former, and is worth more to the consumer for various reasons. So yes, green premiums will be around. There are various government subsidy schemes which will catch up after the RHI subsidy finishes. There's a clean heat consultation, which I think is still ongoing, can't remember. But they're looking at about a kind of a £5,000 grant for putting in air source heat pumps and other renewable technologies at kind of in March of next year. I think that's going to take over from the renewable heat incentive. So yeah, stuff will be more expensive, and the government will have to dig deep into their ever deepening pockets to make sure that this is all possible. And there is so much money that needs to be spent on training and getting people educated and products in. It's eye-watering, but that's what needs to be done. Yeah, so Richard's talking about Part S there, which is this overheating part of the new regs. So he's saying there's a latest edition of the Future Home Standard and consultation document. I would encourage you to look at that. In fact, if you go on the Meshwork, if you drop onto that after the webinar, if you search Future Home Standard, we've got the link to I think the first consultation document. But if you want to read the updated version, no doubt that won't be very far away. In fact, I'll get Catherine, who is the moderator on Meshwork, to have a look for that, and we'll post that up. But good to know there's been an updated version of that as well. And think about tight London sites and stacked flats. Will heat pumps be viable? Noise available roof space? Is the technology efficient for small individual plant, or does it need to be a shared unit? That's a good question, Anna. There is quite certainly on the ground source heat pump side, they have these things called shoebox ground source heat pumps, which allow for a big air source ground source heat pump installation. Then you have these kind of mini units inside the flats, which are literally slightly bigger than the shoebox, but not much bigger. There's all kinds of different solutions that are coming up, but particularly in flats, it does help to have that kind of communal system where you do have standalone systems. You know, you'd have to have a look at that on its own merits. But there are the great thing is as there is more interest in this sector, more product variants will come out, smaller heat pumps will come out, tighter heat pumps will come out, cheaper heat pumps will come out, and there will be solutions for increasingly more and more and more kind of different variants of buildings. So yeah, there are solutions today as well. Is there any, so Glyn's asked, is there any progress on the carbon tax front? Not that I'm aware of, Glyn. You hear stuff floating around. That there's talk about penalizing people who are selling or buying inefficient homes that have fossil fuels in. As I say, that they're invariably, you know, it may be that the fossil fuels get subsidized less and less and less. There will be carbon tax, no doubt about it, but where exactly that will come in, we're unsure at the moment. So watch this space. As soon as we know about that, we will share it with you guys, and the Meshwork will be the place for doing that. Has anybody got any last minute questions? Whilst you type those in, I will just let you know about next week's webinar. Anybody on here who is familiar with R&D tax credits, and anybody on here who is a business owner, runs a practice that designs any kind of buildings, and you're interested in how you can design those buildings more sustainably, we have the fantastic Sue Nelson, who is talking to us specifically about R&D tax credits as part of the sustainable design process. So before you fall asleep, having heard me talk about R&D tax credits, this is about getting free government money for simply designing buildings more sustainably. So we're all going to have to do this, and you'll be amazed by what money you can get for changing your design process. And there are things that you probably already do at the moment that you can claim for if you've been involved in sustainable design. So do drop onto that one. What Sue doesn't know about R&D tax credits isn't worth knowing, but I've promised you guys that it's going to be around sustainable design. We're not going to get lost in the weeds about more general R&D tax credits. It's all going to be focused around architects and sustainable design. So check that out. As usual, say you're going to the event when it comes up to Meshwork, which I think it already is. Kat's already put that up there. And we will see you on here next week. Thanks yet again, folks. We will put the link up to this webinar as soon as we can do. And as always, great to see you on here. And as I say, we will see you next week. Take care, folks. Bye for now.